metal.
Can we knock this? Let's knock the gong. What do you got? Sit down. Tell us the number. How much did you raise?
124 million.
Woo!
So you guys put our ad in our logo in your ad yesterday. We thought we should put you in metal.
Amazing.
That's amazing.
So
Wow.
Nathan, our new engineer, took some time off from customizing cars and
That's so cool.
put this in. Yeah.
Look at
So
this. Wow.
Very,
Get
very,
at the
very,
right
very
angle.
cool.
It's amazing. Okay, so this is metal deforming. Explain what's going on here. Explain what machine made this.
yeah, so we build a machine called RoboCraftsman. It basically does different types of metal operations like a craftsman would.
Yeah.
The core operation is sheet forming. This is a slight kind of indentation to kind of get your logo out, but we can form, aircraft panels,
Sure.
missile airframes, car bodies. We do a lot of customization work with Toyota right now. But the system is designed to do all kinds of manufacturing operation. You kind of think about it as kind of versatile.
Sure.
Manufacturing robot that can do different types of operations just through software.
And what unlocked the new round? Is it a partnership with a big automotive OEM or just sort of broad adoption, unlocking certain technical milestones? Like what jumped off the first slide of the pitch deck?
Yeah, so we're now going actually from kind of like, technology development at this stage to actually scaling, right? So we are deploying at facility number 3, facility number 4.
There we go.
Right, so the third facility is going to be 250,000 square foot facility, which is more than twice the size of our second facility, which is 75,000 square foot right here in the valley. Yeah. We're going to expand the scope of operation. So we initially built a platform to do sheet forming. Now we're adding welding. We're adding assembly, machining, so we can do full end-to-end. Complex metal structure assemblies for our customers. For example, we're doing a lot of work right now with aerospace primes to do missile airframes. So this first facility is going to do that at larger volumes. We're going to do thousands of missile airframes a year out of that facility. But the beauty is that tomorrow you can just switch it and do aircraft panels or do car and automotive panels.
Yeah. Do you want to ever allow someone the flexibility of something that feels almost like 3D printing? You're able to do R&D low volume, but then when someone says, "Okay, I'm going to make the Cybertruck," maybe you need a gigapress. Is that something you want to get into, or is that something you see as like antiquated? We won't need stamping anymore in the future.
Yeah, I think in the short term, I think we could cover up to a few thousand a year of volumes, right? And the big question is long term. What does the manufacturing will look like? My view is that long term, we're going to have less high volume of making the same thing over and over again, and more just keep changing. And you look at the software, how many apps you have on your phone, hundreds. Like you can download thousands from
with software, you used to make it. It would you'd put it on a disc, sell it, and just pray, basically.
Yeah.
Right.
In the future, your car, you don't have a daily and a weekend. You have different panels that you chunk off, change it.
I mean, Jeep does that.
Yeah, they do.
Already ahead of the
great.
curve.
Yeah. So that world is, I think, you look at any sci-fi book, it just tells you about this world where, like every building looks different, every car looks different. There's,
basically a lot more version numbers.
A lot more variety. Yeah. So I think in long term, we're probably not going to have as much of like make the same thing over and over again.
Yeah. When you talk to Lucas Zinger about 3D printing for the hypercar he built, it feels like there's certain trade-offs that he's optimizing for where certain weight to strength ratios are only unlockable with certain structures. They look more organic. What are the other optimization parameters that you're looking at?
Yeah, go for it.
I'm just thinking like cost, speed, flexibility, anything else that's like jumping off the page to the clients.
Right off the bat is just the speed, right?
Sure.
That's why also we started out of defense because that's where you want to have a new idea, a new weapon system. You want to scale it really fast.
Sure.
But not only just scale it fast
quickly, it's like quantize that speed because I've seen the image that I'm conjuring. You can correct me. Is like two massive like sort of robotic arms pushing against this metal sheet, and it's working for like a few hours. Is that right? Is that hours, days, or how long are we?
Yeah. So depending on the geometry, the tack time could be a few hours up to maybe a day.
Okay.
Right.
Yeah.
But you have to compare it to the traditional paradigm time when you have to go make dies and tooling.
Sure.
So now you're looking at 3 months up to a year, depending on how many tools you need, can potentially be longer before you even get your first part.
Oh, yeah, and that wait time's terrible. I've seen that for like even just like plastic forming. It takes forever. Injection molding, like you make the mold that makes the mold that makes the mold. Exactly. Like 7 steps, and then someone goes on New Year, and
it fundamentally comes down to like, okay, what is the dollars went into building a part, because you can horizontally scale, right? So if let's say, hey, I have to spend $200 million to set up a facility and pay for all the dies to get to production. Okay, with $200 million, how many of RoboCraftsman can run in parallel?
Sure.
And that's where it becomes a little bit more relevant, because we get speed through parallelization, versus traditional manufacturing gets the speed through decreasing takt time, right? Like, okay, I do it fast, but I have one assembly line that things go through. It needs to be fast. Versus we're saying, okay, have a matrix operation, have 200 of these cells, same cost, but then to get you same throughput. But tomorrow you want to change from model A to model B, you can just do that.
Yeah. Who are you actually competing with? Is it operations in China? Like, is that like when you're really when somebody's kind of comping you out? Like,
right.
I imagine there just can't be that many super tech enabled kind of manufacturing companies of the future in Southern California, to where I often imagine your competition is overseas.
Right. Yeah, no, so I think, it could be for some of the sectors. In the commercial world, yes. But then in defense, these are already within the United States. So
but I meant more like in auto manufacturing.
Yeah, so I think, going back to your question around like what do we enable, speed is one thing, but a lot of times we also enable something that traditionally was just not possible. Like that's what we're doing with auto, right? Traditionally, you could not go, no matter if you did it in China or here, you still have to make dies. And the unit economics doesn't make sense if you have to customize and make a new die and new mold for every panel or every custom car you're going to build. So in those cases, we're actually creating a completely new paradigm. Like, this is a new business model that Toyota's going after. Like, okay, John or Jordy can go on a website and say, hey, I want this Toyota Tacoma and I want TBPN. You guys have to get fleet vehicles at some point. Yeah. We can do that for you. So put TBPN on the side door. And I want 200 of them, right?
Yeah.
Toyota would be like, this is not it's just not possible, right?
Yeah.
So we're enabling
There's actually a big market, I imagine, thinking electricians, like all these different trades where you would want the custom truck, because you're like, we're going to run this into the ground. It's not like a consumer buying something that maybe they're like, oh, I'll be in it for a few years.
I just want a sticker on the side. We want something that's like permanent.
Right.
Makes a lot of sense. I have an idea of what your CapEx looks like. I mean, you're buying big robotic arms. What does the OpEx look like in a robotic factory? Are you buying a lot of like oil cans, like squeaking wheels? Like what are the parts that break when you're running a lot of robotic arms?
Yeah, so I think like robot maintenance is one part of it, right? Like changing oil.
Yeah.
Every once in a while you have gearboxes that wear out, so you have to change those things.
Yeah.
But
motors too.
Mm-hmm.
Do motors burn out?
Motors actually are pretty. I think I'm working with robots. This company and the previous one, Relativity Space. Yeah. Never had a motor give on me.
Wow. Really?
I've had gearboxes give on me. I've had power supplies give, but not motors.
Because that's when people talk about humanoids, they're often the criticism is like, hey, you have all these different motors that need to function, and they're going to be under a lot of strain, and maybe that's kind of a risk from a depreciation standpoint or just operating expense.
Yeah. I mean, at the end of the day, I think the way I think about it is, if you go like very fundamental, right, the bill of material that goes into making a robot is not that significantly different than the bill of material to go into building a die. The difference is a die and a mold is a dumb material versus a robot is an intelligent material that can change its configuration.
Yeah.
So I mean, it's the same argument even with molds. Like, if you have your gearbox is kind of like, getting worn out, dies get worn out. You have to repair dies, right? So the argument applies either way. It's a question of like which one is a more longer term, ROI, which is usually intelligence has more longer term ROI than a dumb piece of it.
Are you scaling outside of California yet? Or?
Yeah. So third facility is not going to be in California.
Oh, okay.
So volume production, I think obviously California, we have a lot of engineers, so we want our R&D development be here. But productions, we're looking at Texas now for the third facility, New Mexico, Nevada recently, and New Mexico and Alabama.
So. What's the process with those states? Are they getting, or is it fairly competitive? Is there states that are leaning? Because I imagine Texas has a lot of momentum.
Right.
If you're one of these other states, you maybe offer more incentives to get your business.
Yeah, I think Texas has the benefit. Like, we're looking at Austin and nearby area, like Los Angeles. SpaceX used to.
Yeah, people want to live
there.
there. That's
exactly.
a benefit.
But then you go to New Mexico. New Mexico has, actually they have a sovereign fund that can invest into facilities that you're going to deploy. Obviously, taxes are, estate taxes are minimal in all three. Texas has more property-related taxes. So yeah, it's different for each state. But you're right. I think Texas is becoming that premium state. So they value themselves a little bit higher than the rest.
What was the 10-year pitch for investors? Obviously, they're investing based on the, everything you've done to date and the current traction. But if when everything goes right, what does the business look like?
Custom hoods for Ford Raptors. What else do you need to know? Don't even open the doc set.
Right.
Just wire the money.
Exactly. I think what excites us, and also like everybody in the company, right, is the world where when I got out of school, in order to build hardware, you have to work in big companies. Like if you're a software engineer, though, you can have a small team, put stuff on AWS. Suddenly, your app is accessed by millions of people. Yep. If you're a hardware engineer, you have to go work for big companies, Toyotas, Boeings. Why? Yeah. Because your idea requires a lot of capex to be built. So, long-term vision is, can we make that happen for hardware? Can we make what happened with software for hardware, where you have an idea, you go on a portal. Yeah. The AI on it guides you to turn your intention into a design that's manufacturable. Yeah. And you say, hey, I want 200 of these, in Hollywood, California, and the right facility that might be in South Bay or in the Bay Area gets programmed and makes it for you. And, a week later, you get it shipped to your door.
Yeah. Talk about the abstraction layers on top of the robots. You obviously buy robots that are off the shelf. I mean, they're made by large corporations. But once those arrive, I'm sure they have some computer control system. Yeah. Have you had to build an abstraction layer on top of that? Or do you have a translation layer from a design, you put in an image, and that turns it into a 3D point cloud or something, and then translates into robotic motions? Like, what was the process to actually fire it up? Because you're not controlling this with an Xbox.
No. In early days, we did.
Yeah.
But yeah, no. So there's two pieces of software that we developed. So one we call kind of offline programming software, where it takes a design and then modifies the design, then prepares instructions that can be sent to the robot. And then once the robot is done, it gets the results from all the sensors and allows you to do some analysis or even train models afterwards that gives you better process parameters for the next time. Yeah. Right? So that's our offline software. We call it Architect. And then there's a software that controls robots every 4 milliseconds. Look at the sensor data and say, okay, how did you do, and do I want to adjust? Right? And so I can improve it. So both of the software is internal. We did decide to try to be as much as we can off the shelf. So 70% of our hardware BOM is off the shelf. There's 30% like things that the robot pick up, or the way we hold the material, or the whole platform itself, because it's a portable platform. Those are built and designed by us. But we wanted to be able to go to market with limited amount of capex requirements, or something that can be easily financed with debt, as opposed to try to spend a lot of equity dollars on building custom machines. But yeah, so software is all us. Hardware side, 30% is designed, and 70% off.
Yeah. Talk more about the capital sources. What's the role of debt in this business? What's the role of strategic partnerships? It feels like at this level of the stack, we often see companies teaming up with bigger players. What are the pitfalls of that, best practices?
Yeah, I think, that's one of the things that I learned is like a company like this, you need to basically have very diversified capital stack, right? So obviously you get equity dollars for development, but I think the best use of the equity dollars is just put into engineering, build something that gives you long-term moat. Most of our, CapEx is financed with debt, even up to this date.
You get a mortgage, basically.
Yes, you basically get a mortgage against the asset. It's still pretty cheap. Used to be much cheaper. Now it's like, maybe 2%, 3% above the prime rate, right? And then I think customers play a big role. Because we're such a fundamental change.
Are those loans typically interest only, or are you paying down the principal over like 10-year depreciation schedule?
Yeah, so like
you do either.
All flavors, right? So we have like some of them that like a couple of years interest rate only, and then you have 5-6 years of repayment.
Got it. But
just
like a house, but a little bit shorter because it matches the depreciation schedule. Makes sense.
And then obviously you brought customers. I think for us it was actually pretty crucial. Like most of the time people think of, okay, if you're a venture funded business, don't go to customers. They change your direction. Maybe they give you a little bit.
Yeah.
They kind of force you to do things you might not want to do. I think in our case, it's such a fundamental change. I mean, Toyotas of the world, aerospace primes of the world, manufacturing is their thing, right? So I found actually it's better to partner with them and actually get them involved, because some of these manufacturing changes takes 5-6 years to do, right?
Yeah.
So if the executives, even the CEO of the prime is not in it, doesn't have a stake in the company, long term, there might not be, the success might be a little bit iffy, right?
Yeah.
Because they're not committed for the long ride, right?
Yeah.
And then I think the last source of capital, I think, this is, we talk about manufacturing as a national security kind of advantage. So a lot of governments, we work with a lot of governments to provide, kind of certain level of support so that we can deploy these factories in their countries. We recently announced a partnership with UAE.
Oh, yeah. Cool.
So that's going to be where our fourth facility is.
right.
Yeah, they have insane incentives around. They have so much power and so much land, and they just want things to be made there.
Yeah, and they have a huge, that area, speaking of, I call it like, Abrams Accord 2.0, that area is like so much going on there in terms of instability. So all the kind of sane countries in the region are trying to have some level of defenses. And I think UAE is doing a smart thing. They want to become the defense manufacturer in the region next to Turkey and Israel. So spending a lot of money and time on it.
That's great. How big is the company? What's the hiring plan? Big new round?
So right now we are roughly 70 people, planning to get to 240 in the next year and a half.
Wow. Okay, that's a lot of people. Is that manufacturing jobs sort of, is there blue collar element to any of the work?
Yeah. So we still need a lot of technicians in the
Technicians,
facilities.
that's right.
I think, there's a lot of scare when people talk about, kind of AI and like automation. It's like, okay, where are the jobs going? I think we're actually going to see a revival of blue collar a little bit. I think the blue collar is not just going to be not as blue as it used to be. Like they're going to be, they're going to be working with robots and iPads, and they're going to be enhanced. But we still significantly need, technicians, manufacturing engineers on the shop floor operating these systems.
That makes a lot of sense. Jordy, anything else?
No, thank you for this wonderful gift.
This is a wonderful gift. Thank you so much.
On the wall.
Awesome. Thank you.
And
thank you.
it's great to meet in person.
Good to meet you as well.
On all the
Have
progress.
a great rest of your day.